Before our speakers begin, I'd like to note a few logistics. All attendees are currently in listen-only mode. Following our speakers' remarks, we'll open the webinar up for questions. Throughout the presentations, please type in your questions into the chat box, and we'll work to address those during the Q&A period. And finally, this webinar is being recorded. We'll send a link to registrants after the webinar along with the slides. I'm going to pass it on to our first speaker, Jenny.
Good afternoon, everyone, or good morning, as the case may be. Thank you so much for joining us in this third webinar in our Emerging Opportunities series. I'm going to talk briefly about our Emerging Opportunities series, and then, hold on one second. About our Emerging Opportunities series, and then I'm going to give a brief overview of energy efficiency in indoor agriculture, kind of summarizing the findings of the brief that we released this morning. Then I'm going to turn it over to Danny McRae of EPA's Energy Star program. Danny works in the Commercial and Industrial Programs office within EPA's Energy Star, and will let us know about their interest in this sector. And then finally, Derek Smith of the Resource Innovation Institute will talk specifically about efficiency opportunities in cannabis cultivation and the efforts to address energy use in that important and growing sector. So today we released the sixth in our Emerging Opportunities in Buildings series. This series includes briefs on each of these topics. Everything from intelligent buildings to dual fuel programs, residential window attachments. So really a wide range of emerging opportunities in the building sector. Each of these briefs is available along with links to the webinar recordings for each of the webinars we've held on these topics, and is available at the ACEEE website, and you'll receive that link when you get the email about with the specific link as follow-up to this webinar. And finally, I just want to mention that if you have ideas of other emerging opportunities that we should cover in our future briefs or in webinars, please reach out to me and let me know. We're always keeping our eye out for what's coming up on the horizon and where there are opportunities for energy efficiency that we can focus and bring attention to out in the community. So now I'll turn to our discussion of our key topic today, controlled environment agriculture. So just to make sure we're all on the same page, indoor agriculture, or what is often called controlled environment agriculture, there are a lot of different definitions out there, but I wanted to present one that I think is broad and that I liked because it does include the goals of efficiency and sustainability. This is from the University of Arizona. They have a controlled environment agriculture center there, and they define it as the production of plants and their products, such as vegetables and flowers, inside structures such as greenhouses. By using controlled environment agriculture, we can produce high-value crops at maximum productivity in an efficient and environmentally friendly way. And I think that, what I really liked about this one is that focus on efficiency and sustainability. I think that really points to the opportunity for those of us in the efficiency community to work closely with this growing industry to really make improvements that can be beneficial to growers in the industry itself while minimizing the impact on our energy infrastructure. So some of the most common types of facilities I've included here in the visuals. So the background picture is a greenhouse. This is a greenhouse growing lettuce in Chicago. The middle picture is of a vertical farm in New Jersey. This is a very large vertical farm growing herbs and microlettuces. And then finally, on the right, we see a picture of a non-stacked indoor farm, so a single layer farm. And this is a cannabis facility in Oregon. So why are we seeing so much growth and interest in this industry, and why is it happening now? So I think we're really seeing a growing interest among consumers in year-round access to a wider variety of locally sourced food and flowers. We're seeing, folks want to have access to herbs and berries and other products, and they want those to be grown within a small radius of their homes so they can have more fresh produce. We're also seeing concerns about food security and safety. And then we also see indoor agriculture being promoted as an urban economic development strategy in a number of our cities. And finally, with the expansion of legal markets for medical and recreational use cannabis, we see a lot of growth in that market as well. So all of these are driving this interest in controlled environment agriculture. So what does that mean for energy consumption? So energy use in these facilities is really driven by a number of factors, primarily the cultivation method, the facility type and size, and the crop that's being grown. And the estimates of overall energy use vary widely. A recent ACEEE study estimated that a typical container farm may consume 45 megawatt hours per year, while more intensive vertical farms could use as much as 8,700 to 70,000 megawatt hours per year, depending on the size of the facility and the crop that's being grown. In the same ACEEE study, they found that energy costs were estimated to account for as much as 60% of facility costs. But we find that a smaller survey of indoor food producers conducted by Agrilist found this range from 8 to 25, as shown on the graph on the left. So really a wide variety. And I think what this really shows is how much more data is needed on energy use in these facilities, what portion of facility investments go toward energy. The biggest consumers of energy use in these facilities are lighting, HVAC, and dehumidification. And some of the barriers facing the industry include capital constraints, lots of capital constraints on food and flower producers as they show that these facilities can be profitable, capital constraints in the cannabis industry where there's limited access to banking due to federal regulation, managing environmental conditions and pests. The same Agrilist study found that second to capital constraints, maintaining a good indoor environment, the adequate indoor environment for plant growth and healthy growth is a big challenge, as is in maintaining a safe environment for the plants, minimizing pests, mold, mildew, fungus, and so forth. So those are, that second category in particular, I think is something where the efficiency community has something to offer with our knowledge of building science and some of the technologies and tools that can help really improve that indoor climate. And then finally, energy costs. With costs making up that much of the operating budget, it's clear that that can be a barrier to the industry, particularly when capital constraints are in the way. So I'm going to run through some of the opportunities that we see on the technical side for reducing energy consumption in these facilities. First is lighting efficiency. Lighting is widely accepted to be the leading energy user in these facilities. DOE estimates that a shift to LEDs would produce 40% savings at the national level. Case studies validate these savings at the facility level. We see that savings in facilities that have made a switch to LEDs are on the same order as the savings we see in this graph. The biggest opportunity is in non-stacked indoor farms, where we see savings at the national level of about 40% from a switch from HPS to LEDs. And we see some case studies with savings as high as 60% in lighting energy consumption. Greenhouses have the lowest operating hours, so they're a mid-range opportunity. And then vertical farms are the smallest opportunity, but that's largely because these mostly use LEDs already. They're sort of one of the nature of the business of a vertical farm is using LEDs. So we really get savings from moving from HPS to LEDs, and then also when LEDs allow a shift to a two-tier farm or even a move to a vertical farm. So there are lots of opportunities for farmers that may be interested in increasing yield by moving to LEDs, doing stacking, and then they're able to produce a much higher yield in the same footprint. Additional benefits of LEDs include increased crop yields, as I mentioned, operational savings due to the longer lifetime of these products, grower flexibility due to the tremendous color tuning opportunities with LEDs and the opportunity to do stacking and other types of arrangements. And then finally, water savings that are also come about from the reduced heat load of LEDs, as well as that ability to stack and reuse water in an indoor facility. On the HVAC and dehumidification side, we see a different set of opportunities. The use of high efficiency variable speed rooftop units and chilled water systems. Many growers may be relying on systems that have been designed for typical buildings, typical air conditioning units, and there could be issues with those. They may not be the most efficient rooftop units, for instance, but we're seeing the emergence of a number of products specifically developed for indoor agriculture. And these include integrated systems that provide advanced cooling and dehumidification, such as this product from Desert Air, pictured here on the left. This is their Grow Air system, and it combines sophisticated controls. It can even be incorporated into a building management system, along with advanced cooling and dehumidification to deal with the type of latent loads that we see in indoor agriculture facilities that are unheard of in typical buildings for human occupancy. High efficiency freestanding ductless dehumidification units are another option. And then finally, elimination of electric reheat in favor of hot gas reheat or other heating technologies. And we see those being incorporated in many of the new specialty products designed for this market. A few other efficiency opportunities relate to some unique end uses in this industry. CO2 injection. Many facilities will inject CO2 into the space to increase crop yields. And there may be opportunities to reduce energy consumption associated with that, whether they're using bringing in tanks to provide that CO2 or using gas-fired equipment to produce CO2. One opportunity is co-location with other industrial facilities that may be producing CO2 as a waste product that could then be captured and used in these facilities. Ceiling fans are an important way to maintain proper air movement across plants. Really, when we think about these facilities, you're trying to recreate the ideal outdoor environment for each crop inside of a building. So not only does that include the right temperature and very careful temperature control and lighting levels, but also proper air movement to simulate what wind offers plants, for instance. Air filtration is also important to pest management in particular. And then finally, odor control is a major option, major issue in cannabis facilities in particular. And finally, as products are processed and packaged, we think there may be additional opportunities for efficiency there. So one of the key areas, I think, for contribution on efficiency initiatives is really to try to address industry needs while meeting the energy targets that those of us in the efficiency community are interested in. And some of the things that are needed to do that are performance indicators and targets for facility energy performance, best practices to show growers how they can implement energy efficient practices. And each of these I'll talk a little bit more about how what we're beginning to see in the market to offer these services and resources for the industry. Efficiency program investments in measures that increase efficiency without sacrificing yield. And I think that's something that may be top of mind for those who work closely with industrial sector programs, but is a little bit newer for folks on the building side. And I think there's a lot of interesting overlap between building and industry approaches to dealing with this market. Energy use reporting can address data gaps and facilitate improved decision-making and policy development as we move forward. And finally, research development and demonstration. So I think these are all the things that we're looking for and really looking to build an infrastructure to help facilitate market transformation in this industry. So I'll talk about some of the things that are being done now. So lighting. One of the most important things, and we've seen this time and again throughout, with efficient technologies, is the need to have appropriate test methods and metrics as a starting point for addressing energy consumption in any end use or industry segment. And this is a particular issue within lighting for these facilities. Most of our lighting efficacy measures are based on human measurements, based on lumen efficacy. And as this chart here from Fluence, one of the leading LED manufacturers servicing this, this industry, the range of wavelengths for lumen output as measured for humans is much smaller than that used for photosynthesis by plants. So one of the things we like to say is lumens are for humans, and we really need a different metric to determine the efficacy for these products, for lighting products that are serving for photosynthetic growth in plants. To that end, the American Society of Agriculture and Biological Engineers has completed 2 of 3 industry standards, and they've established the units of measure and test methods for horticultural lighting products and are now working on performance metrics, including efficacy metrics for horticultural lighting. So as those enter the market, that's really going to help provide, they're helping to provide the basics that we need to understand efficiency opportunities and gauge product performance. There will be opportunities to do similar things for some of the specialty HVAC and dehumidification equipment that's being designed to service this market as well. But one of the great developments that we've seen as a result of this test method development and metric development is emergence of certification and listing programs like the Design Lights Consortium's Horticultural Lighting Program, which they launched in the last quarter of 2018. This offers testing and reporting requirements for horticultural lighting. They've established specifications for energy efficient horticultural lighting, all LED based. And to date, there are 6 manufacturers on the qualified product list and 21 products, and we'll expect to see many more in the coming months. DLC is also offering resources for growers to help them identify and implement the most efficient lighting designs for their facilities. And we're seeing program implementers get into the action as well, with a number of program offerings targeting controlled environment agriculture. Custom incentives are the most common at this point. We see programs offering anywhere from 10 to 25 cents per kilowatt hour saved and $2 per therm saved. Most of these programs cover up to 50% of project costs. And most are based on modeled or projected savings. We see offers of technical assistance to help with lighting design, appropriate HVAC sizing and design, and so forth. We also see programs offering prescriptive rebates for lighting controls and fixtures, and then some for efficiency measures specific to greenhouses. And that would include anything from the special light curtains that are used in greenhouses to greenhouse covers, greenhouse heating equipment, and so forth. Some of the programs and incentives that we see to date are specific to cannabis facilities, not all. Some program implementers, like the Energy Trust of Oregon, have a broader indoor agriculture program, but then they have other other incentives targeted specifically to cannabis growers, where we see others like the ISO in Ontario offering a program that covers a broad range of facility types, including cannabis and other products. But I mean, one of the things you will notice is that each of these leading program areas, program administrators that I've included here on the slide, are all in jurisdictions with legal cannabis markets. Finally, I think it's important to look at what the demand response opportunities might be for these facilities. Once you're growing in a warehouse and using entirely artificial lighting, you have the opportunity to make daytime and nighttime any time of the day that you want, and that can offer some really interesting opportunities for demand response, for use of intermittent renewables, and so forth. So there's some really interesting opportunities here. And one other thing I'll just mention is that we're seeing increasing use of the DLC qualified products list as a marker for products that will qualify for prescriptive incentives in these facilities, in these programs. So finally, another thing we need is data. We need data on how these facilities are using energy, what the main end uses are, what the best opportunities, the best ways to get those savings, and to benchmark facility performance across the industry. And so we're seeing the emergence of things. I won't spend much time here on the Cannabis Power Score, because I know Derek will cover it in his presentation, but we're looking at ways that we can use this data that's being collected to develop best practices, to be shared with growers, how data can be used to offer recognition programs such as Energy Star recognition, which Danny will cover in a moment, and finally to do that sort of benchmarking. So we're starting to see this effort to do this for cannabis facilities, and can see that grow to cover a broader range of indoor farms. And then finally, I just wanted to do kind of a check-in on where we are in terms of, I made a list of sort of what I would see as the prerequisites for market transformation. I think we see that there are available efficient technology options out in the marketplace now, and we're beginning to get a pretty good understanding of the barriers and challenges, although, this is something that always needs to be revisited, and through conversations with growers, see how those challenges may be changing over time. We see proper test methods and performance metrics. We're really making a lot of progress on the lighting side, and some of the other products, we're beginning to look at ways to develop much more specific metrics and measurements for those as well. Product certification and labeling, again, for some products but not others. And we're seeing program support from a limited number of utilities and program administrators to date. But I think where we really still need a lot more work is getting that data that will allow best practice and recognition programs, and will also allow us to set policy that is well formulated, well designed, and can really lock in and scale up the savings from this important market sector. So that's it for me. Now I'm going to turn it over to Danny, and we will hear more about opportunities and the interest that Energy Star has in this market segment.
All right, am I unmuted? All right, it looks like I am. So thank you for the introduction, Jen. My name is Danny McRae, and I am with EPA's Energy Star program. So I'm going to give you a brief overview of how Energy Star supports industrial facilities around energy efficiency. And then I'll talk a little bit about how indoor agriculture facilities, specifically those that grow produce, can get involved with Energy Star. And just to say up front, given cannabis's status federally, our efforts would need to focus primarily on facilities that grow non-cannabinoid products. So next slide. All right. So Energy Star, for those of you on the call who aren't aware of all of our program offerings, it's a voluntary government partnership program that was created in 1992. We focus primarily on promoting energy efficiency within consumer products, within residential homes, and within buildings and plants. And Energy Star has a 90% brand recognition, so when people see the Energy Star logo or hear of Energy Star, they usually connote that with energy efficiency and saving money. Next slide. So I just explained generally what Energy Star does, but let me tell you a little bit more about how we promote energy efficiency within the manufacturing sector. So our goal is to help manufacturers, both large and small, and companies that have been long established or are just starting up, to improve energy efficiency and save money in their operations. And we do that by helping companies develop strategic energy management plans in their organizations. Now, when I say energy management plans and energy management programs, I'm not talking just about identifying energy projects such as lighting upgrades or installing VFDs on pumps. What I'm talking about is how do you create a program so that you can create a culture of energy efficiency in your organization. So energy is something that you manage and that you're thinking about every day, not just when you are installing a new piece of technology or when you're doing an audit. So to help companies develop these energy management programs, we have a set of guidelines on our website called the Energy Star Guidelines for Energy Management, which go into details of how you go about doing this. So generally, building an energy management program in your organization includes making a commitment to energy efficiency, which means having a policy on expectations for energy. It involves tracking energy on a regular basis and having staff where at least part of their formal responsibility is to manage energy and track against your targets. Next slide. So we've worked with hundreds of companies over the last decade on developing energy management programs, and we've worked with sectors all the way from bakeries to oil refineries. And when they've used the guidelines for energy management and when they've used other Energy Star schools, we see a lot of tangible savings. So these are just some examples of companies who we've worked with who are able to gain monetary savings from working with Energy Star. So we have Bimbo Bakeries that saved $3 million by using an Energy Star treasure hunt tool. And we have dairies who reduced their energy intensity by 10% within 4 years through our Challenge for Industry program. All right, so next slide. So outside of the guidelines for energy management, we have other resources as well. We recognize top energy performers in certain sectors by certifying those plants with Energy Star certification. For plants that don't fall within those sectors, we provide recognition if they can improve their energy performance. And within our Energy Star partnership program, we facilitate best practices between our partners. And then finally, we have a certain set of industrial sectors where we develop specific resources to help them with their energy management and energy efficiency activities. So next slide. This slide shows the list of sectors that we have worked with and we currently work with around energy efficiency. And every year, we like to add one or two more sectors where we'd like to work with them specifically around energy efficiency. So we are thinking about adding indoor ag facilities that grow produce to this list. And we're interested in indoor ag for a few reasons. Jen went through these, but we know that the energy intensity for some facilities are extremely high. And unlike other sectors, indoor ag has more flexibility to participate in facility demand management programs. So that's fairly unique to this sector. And then also indoor ag is a new sector. And this would be an opportunity for us to work with companies that are just setting up their infrastructure, just setting up their energy tracking systems. So it'll be very different than working with an industry that has been long established and where there needs to be a lot of changes. So if we go to the next slide, I'm going to talk about things that existing indoor ag facilities can do with Energy Star. So even before we would have a potential focus, these are things that indoor ag facilities that grow produce would be able to participate in. So the next slide shows one way to participate with Energy Star is to become an Energy Star partner. Energy Star partners commit to develop an energy management plan and to measure and track the energy performance of their facilities. The benefits of being a partner is that partners are part of the Energy Star network, which allows you to attend our best practice webinars and meetings. And during these sessions, you get to hear from other Energy Star partners in the manufacturing sector on how they set targets and different energy efficiency projects they are doing and get ideas for them. As an Energy Star partner, your company would be able to use the Energy Star partner logo in communication. So again, thinking of the brand recognition of Energy Star, this is a great way to help to showcase your commitment to energy. And another great opportunity is if you are an Energy Star partner and you're just starting out, figuring out how to develop a program, you could be mentored by another Energy Star partner that has a long-established energy program. So this is an opportunity not just to hear from us, a third party, how you should structure your program, but to hear someone who has skin in the game, someone in the industry to see how they did it. So if you are interested in that, you could go to energystar.gov/join, or you could email me for more information. The next slide shows another opportunity to participate currently, and that's within our Challenge for Industry. Facilities that participate in the Challenge for Industry commit and are able to reduce their energy intensity by 10% or more within a 5-year period. So for an indoor ag facility, this would be reducing the amount of energy per square foot or per pound of produce produced by 10% or more. So if you enter the challenge and you can't meet it, there's no penalty. You could always join again. But if you do meet the challenge, the facility would receive EPA recognition. It would receive a certificate of completion. The facility and company would be listed on our website, and the CEO of the company and the energy program staff would get a congratulatory letter from the EPA. If you go to the next slide, this shows companies that have participated and have achieved the Challenge for Industry. Over 500 facilities have achieved this to date, and they range from very small companies to large ones in all different sectors. We don't have an indoor ag facility in the challenge as of yet, so if there's anyone on the call that's interested in participating, it'd be great to see if you could be the first indoor ag facility to meet the challenge. So I'm going to wrap up with talking about potential activities, and this would be on the next slide, talking about potential activities we could do within an indoor ag industrial focus. So again, these are things, if we want to focus, Energy Star wants to focus more on indoor ag, these are some things that we could do specifically with this sector. And again, this would focus mainly on indoor ag facilities that are growing produce. So the first thing is, if we go to the next slide, we would have a focus group. We would have a group of indoor ag facilities within Energy Star, and this could be a forum where these companies can share best practices for managing energy. So on the slide, there are a few topics that we could discuss. We could share within each company who's in charge of managing energy. What are your energy, your greenhouse gas reduction targets? What kind of reports do you receive on your energy use, and how do you interpret those reports so that you could find no-cost or low-cost ways to make reductions? We could also bring in outside experts on a certain technology if there's interest in that, or we could bring in other Energy Star partners to share what they've done for any systems that may overlap between your industries. On the next slide, another potential opportunity we could do is to develop an energy guide. These guides would list best practices that are unique to a particular industry on how they save energy. We've done these guides for 18 industries already. On the slide, you see the energy guide for fertilizer production activities. So if there is interest, we could do a guide for indoor ag. On the next slide, it shows that we could potentially also develop an energy benchmarking tool. So the next presenter is going to talk about a commodity-specific indoor ag benchmarking tool. But outside of that tool, Energy Star could potentially develop a benchmarking tool for facilities that are growing produce. So having a tool like this would allow a facility to get a score on a scale from 1 to 100 to show how your energy use compares to facilities with similar characteristics. So if you get 100, that means that you're at the top of the game. If you get a 50, that means your energy use is about average. So what's the benefit of this? The benefit of having a score and being able to benchmark your facility is that you may think you're doing everything you can to be energy efficient, but when you get your score, if it's a 50, it tells you that there are other facilities that are doing something better. So it probably means that there's a lot of money you're leaving on the table as far as energy that you're spending. If we were to do this, it would require a lot of collaboration and input from the indoor ag sector. We would need to work with you guys to get data on these facilities so that we would be able to develop a model so that going forward, people would be able to put your data in the model to see where you fall. So again, if there is interest, that's something that's a potential activity. And then the last slide is if you are not an indoor ag facility, but you're a service provider or a supplier or part of another efficiency program, there are other ways you could get involved as well. If you're a service provider, so you are helping a client reduce their energy intensity, you could work with them to enter the site in the Challenge for Industry as a value add. So you're helping your customers save money, but you could also help them earn EPA recognition from their investment. If you are a supplier, we mentioned that we may be interested in putting together a set of best practices. It would be great to get your thoughts on that. And even though we can't list specific brands, we can talk generally about technologies that promote energy efficiency. So with that, the last slide has my contact information. If you are interested in participating in the challenge or becoming a partner, email me. If you are interested in being part of a future Energy Star Indoor Ag Group, please let me know. We only develop these groups if there's sufficient interest from the industry, so it would be great to know if who is interested and what kind of resources you would find beneficial.
Great, thank you so much, Danny. Appreciate that. And now I will bring up Derek Smith from the Resource Innovation Institute, and we'll hear more about efficiency opportunities in the cannabis industry.
Thank you, Jen, and thank you, Danny. That was very interesting. Hello, everybody. As Jen said, my name is Derek Smith. I am Executive Director of Resource Innovation Institute, which is a market transformation nonprofit based in Portland, Oregon. We are essentially bringing together cannabis cultivators and operators, the supply chain, governments, and utilities to accelerate conservation in cannabis, which is, as many of you may know, is one of the fastest growing and most dynamic industries in the world, almost literally spreading like wildfire all over the planet in terms of regulated markets opening up almost on a daily basis, including at the federal level in many countries. Next slide, please. So our mission is to advance resource efficiency to create a better cannabis future. Part of that better cannabis future is obviously energy and carbon savings. It's also helping to resolve some challenges that happen at a local community level where this plant is being introduced, and also hemp is being introduced, and people are smelling the plant. They're having concerns about that odor, energy grid disruptions, water usage, etc. And there's really no way for anybody to understand and measure and compare which of these farms are being efficient at this point. So we're out to solve that problem. We've been around for 3 years. We are proud to have Jen and ACEEE on our board, as well as the California Cannabis Industry Association and a former U.S. Green Building Council board member, as well as an energy policy advisor to 2 Oregon governors. We have funding from governments, utilities, foundations, and industry leaders, and we are moving fast as this industry moves fast. Next slide. So part of what we do is to inform the market about how much energy is being used in this sector, and we'll tell you a little bit about how we're gathering that data. As Danny mentioned, we're using some benchmarking data that we have been gathering. Last year, at the end of last year, we published a report called the Cannabis Energy Report with New Frontier Data, which is one of the leading data analytics firms in the industry. And basically, you can see on this graph that, we're looking at 162% increase, basically from here going forward in terms of electricity use, unless we do something about it. And the reality is, there's a lot we can do about it. We just have to act urgently and collaboratively and to make it happen. Go ahead. So I'll share with you some benchmarks now that have come from our Cannabis Power Score benchmarking tool that was mentioned earlier. And just to give you a sense, so these box plots are showing you the range within the 3 different methods of cultivation. We're talking today about indoor ag. What I'm showing you here is a range of electricity intensity from indoor to greenhouse to outdoor. And so you can see the average or the mean is 262 kilowatt hours per square foot of flowering canopy for an indoor facility, and all the way down to an average of 2 kilowatt hours per square foot of flowering canopy for outdoor. That delta can actually range 500x. I mean, essentially, you can be growing this plant outdoors with 0 electricity impact if you're dry farming and not doing a vegetative cycle under artificial lights and doing essentially everything outdoors. That's not the common practice. There is generally electricity used and definitely energy used in all of these methods of cultivation. Electricity is what we've been studying the most, and we're moving now into studying other forms of energy use. But this gives you a sense of that range of electricity intensity, and it's essentially, old school basement type models being blown up to 50,000 square feet in Denver when this first got started, half a decade ago. Is the old outdated model, and that is changing rapidly. And so to get a handle on these benchmarks, we really need to study more and gather a lot more data. Go ahead, please. So that was electricity intensity. Now I'll show you electricity productivity on a grams produced per kilowatt hour basis. This is the range across these 3 methods of cultivation. I should say that our data is largely warm climate based. It skews West Coast. If you look at the the regulated markets for adult use cannabis in the US, we've been tracking those markets, and a lot of them are still coming online. So we're gathering more data from newer markets like Massachusetts and Michigan, as well as Canada, and these numbers will continue to be updated. Go ahead. So essentially, I'm going to go through these 3 slides really quickly. Essentially, we're helping cannabis farms transition from that old school model that I just told you about into this LED, vertical stacked, automated model, and we're studying all the impacts of those different techniques. Go ahead. We're also helping transition farms to greenhouses, with which increasingly outdoor farms are moving into a hybrid model, and frankly, indoor farms are increasingly moving into a hybrid model where they're using some elements of cultivation are indoor, some stages are outdoor, some in the summer, some stages are in greenhouses with light deprivation curtains and artificial lighting to get more harvests per year, as was mentioned earlier. So A third alternative that we're helping farms move toward is the next slide, which is really this small-scale regenerative outdoor farm. And so we're studying, as I said, all these different approaches. Go ahead. And I think it's already kind of been mentioned, but what we know very clearly is that cannabis is the incubation platform for our agricultural future. Everything that we are learning in this market, which is changing so dramatically and which generally has private sector funded R&D that the government and utility sectors can leverage. You know, everything we're learning here, it can be applied to the broader interest in controlled environment agriculture, as well as these regenerative soil practices outdoors, but also indoors. Go ahead. So, but there are challenges to transforming this market. Not only is it moving so quickly, as I just mentioned, but there's really, except for what we're doing, there is essentially a lack of data on energy. As Danny mentioned, you know, the federal government here cannot look into this. We're beginning a conversation with the country of Canada, which we're very excited about. They're beginning to look at this. But there's also not just that lack of data, there's also a culture of secrecy and a culture of hiding information because these growers were fearful of being caught. So there's been a long history of working with utilities, but it's always kind of been don't ask, don't tell. And so therefore there's very little documented best practice, and we'll talk about that in a couple slides. Also, no existing policies or codes, although that is changing now. Massachusetts, as many of you may have seen, has stepped forward to put together a policy, and they're about to update those rules, which is very exciting. And we see that as setting the table for the way controlled environment agriculture broadly is going to be regulated. And yet, despite those actions, we see less and less these days, but inconsistent engagement by utilities and governments generally because of federal concerns. Go ahead. So our market transformation philosophy, what our theory of change is that we need to focus in three areas: data, policy, and education. And those are the three key elements to accelerating this energy efficient, low carbon cultivation model going forward. So I'll tell you about each of those real briefly. So the Cannabis Power Score is that benchmarking tool. It is the world's largest data set on cannabis energy use. We have about 250 farms that have given us detailed information about the lighting they're using, the HVAC systems they're using, the size of their canopy, the size of the rooms, the type of building they're in, if it's a new construction or an old barn. And we're taking that aggregate data and we're informing governments and utilities and others so they can actually make decisions that are based on data and based in reality. And through that aggregate analysis, we're also validating technologies and techniques. And so you can see the graph at the bottom left, the little chart, is actually showing not only that LEDs are saving the money or the energy that is predicted by the U.S. Department of Energy, the 40%, but also that electricity productivity is more than double from an HPS light to an LED light. Go ahead, next slide. Just to show you two quick studies from the Power Score, and just to also emphasize the range of electricity use, it's certainly based on technology. This is one of those old school facilities that we're seeing less and less, but it is still a dominant way that the industry is producing. And new facilities are still getting built like this. This has high intensity lights and a very inefficient HVAC. Very low score on our Cannabis Power Score. The next farm you'll see is with LEDs, with automation, with vertical stacking, more of a small room pod style growing, and much higher score, much higher efficiency all across the board. So we really want to peel back this onion and understand these differences and make decisions based on this. Go ahead. On the policy front, we advised the state of Massachusetts as they came out with their initial rules, which were essentially based on a commercial industrial model of watts per square foot. And we helped them evolve that to photon efficacy being an additional thing that should be looked at. We brought together 25 industry stakeholders, including LED manufacturers, HVAC manufacturers, ACEEE, other policy folks, cultivators, architects, engineers, and advised on a full regulatory system that could actually emphasize data collection, increasing targets over time, exemptions for renewables, and definitely make these connections with incentives. The utility incentives are critical in this market, and what we can't afford to do is essentially establish code without ensuring that there's some technology adoption acceleration that can happen via incentives. It's critical in this market because there's so much resistance to LEDs. Go ahead. And so with that, we're working closely with the Design Lights Consortium. Oh, it looks like the slide got a little bit messed up. We are also educating the market to accelerate adoption. So we have peer-reviewed reports. We just put out this LED primer document, which is essentially saying to cultivators, if you're thinking about LEDs, these are all the things you need to know. This is what you need to know about incentives and financing and the DLC qualified product list and all these other things, quality impacts, et cetera. This year we'll be producing best practices guides, which are with all of those market actors that I've already mentioned, sitting around tables and determining how you adjust HVAC and water and nutrients when you go from an HPS environment to an LED environment. And we definitely want to support the move toward prescriptive incentives, and we think we're getting close on that front. We'll be putting together a large indoor ag summit for governments and utilities early next year, so look out for that. Further on the education front, next slide, we put on events called Efficient Yields, where we bring together growers to essentially to teach other growers what's working for them, how they're being more efficient. And this is becoming quite popular. We've had the support of Energy Trust of Oregon, thankfully, in Oregon. And now we're moving to other markets with other utilities, and we're excited about the interest in this model because, as Jen said, really no best practices being conveyed, and this is an excellent venue for that. Go ahead. And I should say they're non-commercial, and we have the supply chain engaged, but it is an open format where we're talking about advancing the industry, not anyone's individual products or services. So here's some things we're learning, and then I'll wrap up. You know, there's really no way to validate how good a grower is yet. There's no real metrics to do that. So growers all claim that they have the most efficient methods or the best methods, and the investors believe them. And so that tends to go back to old school technology and a resistance to new technology. And we essentially need to make it cool to try new things and to be innovative and to be efficient. And that's easier said than done. Like I said, we are seeing the LEDs are saving energy, but they also may be improving quality. We're seeing that vertical stacking is definitely saving electricity, but you know, we're seeing mixed results on the improvement of production. I think that could be a factor of training, and I think there needs to be some standards around that. Similar with automation, it's yielding mixed results. You know, we're seeing some cultivators not really understanding HVAC at all, and maybe setting inadequate control points. So I think there's a lot of training, a lot of best practices that need to be instilled. Go ahead. Got a whole host of recommended research. I'll just point out that somebody needs to step forward and invest in a baseline study. Nobody has done this yet. We're in some decent conversations about that, but it would be great if folks wanted to collaborate on that. We have a platform where we could do that. And also to make sure they engage growers on efficiency at hookup, because once they choose that HVAC system and it's sized to an HPS environment, and we missed the boat on getting them to size HVAC according to an efficient lighting model, they're living with it, and we're living with systems that are fighting each other. And I'll save you from the rest, but you see the list here. I think that's my last slide, and I think we're nearly out of time. So there's my contact info. I'm happy to talk with anyone further, and thank you again for the opportunity.
Great, thank you so much, Derek, and Danny, for those great presentations. So we have a couple of minutes, and we don't have a lot of questions, but if anybody has a question, you can try to type it in. If we don't have time, we will try to follow up with answers to the extent that we can. One question has come in. What percentage of new projects are using LEDs? And this is a question, at least on the non-cannabis side. I've looked for an answer, and I wasn't really successful in finding one. But Derek, do you have a sense of that for the cannabis industry?
Can you state it again? Sense of what?
What percentage of new projects are using LEDs?
Oh, LEDs are definitely on the rise. I would say it's probably in the neighborhood of 10%. It may depend on the stage of cultivation. We're seeing that the vegetative stage, people are getting more comfortable with it. And in the flowering stage is really where the trick is. And that's also where the largest square footage is in a facility, and also where the most energy intensity is. But it's the resistance is breaking down, and it's partially because of all the cost pressures in the market. And also the case studies are really helping. Okay.
Now we're getting a lot of questions coming in. One is on, let's see. Have you seen any implementation of radiant heat systems for indoor ag up north? Well, we are starting to see a lot more growing happening in the north. Have you heard much about that, Derek?
I've heard of a few instances. I have not seen any facilities, and I don't have any data on how they're performing.
Mm-hmm. And what about the use of lighting to control pests, such as powdery mildew?
I have heard anecdotally that there is that benefit. I couldn't speak to the veracity of that.
Right. I do know that in some of the lighting manufacturers that are focused on this market have included, have some information about pest control in some of their case studies. So that might be one place to look, is to see what research or findings those vendors have found.
Mm-hmm. Agreed.
All right. So that wraps up our time, and I don't want to keep people over the allotted time. I want to thank our speakers again. Thanks, Danny and Derek. As we mentioned, all of this stuff will be available online on the ACEEE website. We'll have a copy of the slides, as well as a link to the webinar. Will be sent out, a link to the webinar recording will be sent to all of our registered participants. And to the extent that we can, I will try to follow up with a couple of people on some of your questions that you've submitted here in the last few minutes. Thank you so much, and I look forward to interacting with you all in the future. Thank you.
Thank you.